So in this case, we are going to consider a typical exam revision, which is important as we are preparing ourselves for the exams which are ahead of time. So if we are to consider, that is the province of KZN that we have, and that is the Zululand district. So that was a typical exam which they wrote in September 2024, which, as we do understand that most of these typical questions, they are going to be a repetition in terms of how they are given. So just make sure you do revise as you are given your ATP. You know that you're supposed to work out all the topics of your term 3. So that was it, guys. Read the following instructions carefully before answering the questions. So make sure that you read each and every instruction that you are given. So that was the first part. And the first question we are given, 4 options are provided as answers. So we have got answers, that is A, B, C, and D. 4 options to the following questions. So circle the letter corresponding to the correct answer, meaning to say we need the one that is exactly equivalent to what we are given. So without wasting your time, guys, question 1.1, we are given 2x, 2 into 5x, actually 2 into 5x minus 3 is equal to what? So of these answers that we are given, what are we given here? What is it that we have? We are given an expression. There's an expression. This is not an equation where we are given 2x minus 5, then it is equal to a certain number. Then you're asked to solve for x, right? When we have got something like this, if x minus 8 is equal to, there is something that they are equating to, then x is equal to, this one is an equation. You're supposed to solve, to state the value of x, which is different from this part. It is a simplification, simplify. So what is it that you're supposed to do? Just expand the brackets, then you can collect your like terms in case that we have got the like terms. So distributing the 2 into the bracket, we're going to multiply each and every term. So that's 2 times 5x, which was going to give us 10x. Then 2 multiplies the minus 3, and that was going to give us what? Negative 6. So this is the equivalent of this part that we are given. So that is 10x minus 6, which was on C. Then moving on to question 1.2, like I said, this one is an equation. So we are given that if x minus 8, if we are given x minus 8, which is equal to 11, then x is what? Solve for x. It is an equation where you are supposed to solve for x. Determine the value of x which satisfies the equation that you're given here. All right, so we do understand from our linear equations, we can take the minus to the other side, the minus 8. The moment it jumps the equal sign, it must change the sign that we are given. So therefore, x is equal to 11. The moment we take this to the other side, it becomes what? A plus. It changes the sign that you're given there. Already the 11 on its side, on the right hand side, it's already a positive there. It is not changing. So therefore x is equal to what? If we add 11 plus 8, that is 19. So of the answers that we are given, that's B. It was going to be the best answer, where we have got a 19. All right, moving on to 1.3. Consider the figure below. Choose the correct statement, the correct one, about what we are given on this figure. These angles that we are given, all right, so there are so many statements. It's not only about angles, it's also about the sides. So let us just focus on the statements that we are given, which one is correct. The first one, which is on A, they're saying angle Q1 and this angle Q2, they are equal. Is it correct? So this is not. These two angles, they are just on a straight line. Where on a straight line, we do understand that these angles, angle Q1, if we are to add this to angle Q2, we must obtain 180 degrees if it is about these two angles. Not to say they are equal, so this one is wrong. Another statement is about the line PR. From P to R, it is the same as from Q to S. These two lines, they're equal. There is no statement to prove that these two, they're equal. So this is totally wrong. And on C, angle Q2 is 90 degrees. This is totally wrong. If we were having something like this, a right angle, that's where we can say we've got what? A 90 degree. All right, the last one, angle Q1 when added to angle Q2, we must obtain 180 degrees as I was stating here. So that is the correct answer that we are given, which is on D. Truly, these angles, they are on a straight line. So if I add these two angles, I must obtain 180 degrees. That's angles on a straight line. Angles on a straight line. So I'm just going to write in short. All right, let's see 1.4 on the other part of the question. So guys, you just need to work out as many questions as you can. Just try to understand these questions. 1.4 are given. Which statement is not, take note, which one is not correct regarding the triangle that we are given below? This triangle that we have, we can see that there are sides which are equal. This side is equal to this one. It is equal to this one. Meaning to say, definitely we are referring to an equilateral triangle. What are the other properties that we do understand? Each and every angle must be 60 degrees for an equilateral triangle. All right? All of the angles will be equal. So if we take 180 degrees, divide by 3, since 3 angles are equal, this is going to give us what? 60 degrees each angle. So that's another property that we can opt from the equilateral triangle. So here they're saying, which statement is not correct? On A, they're saying angle E is 90 degrees. The angle that is at E here is 90 degrees. No, that is wrong. Each angle must be what? 60 degrees. So meaning to say this is wrong. It is not correct. So on our answers, they want the part which is not correct. So A will be our answer because it is not correct. E cannot be equal to 90 degrees. All right, let's check B. All sides are equal. It's an equilateral. As we are given these lines, it shows that all the sides are equal. Angle D is 60 degrees. Truly, angle D is 60 degrees. All angles are equal. So these properties, they are very true as we are referring to the triangle that we are given below, which is what? An equilateral triangle. But the first statement is not correct. So A is not correct. All right, on 1.5, let's consider another part of the question. As we are revising, we must attempt as many question papers. Just try to see how do they ask these questions. 1.5, we are given a quadrilateral with one pair of parallel sides is called what? It only has one pair of what? Parallel sides. Only one pair. So that's what? A trapezium. So the best answer there was a trapezium. At kite, we do not have parallel sides. A square, it is both. It is actually having two pairs, not one pair, but what? It has got two pairs of parallel lines, which is the same thing. On a rhombus, it has got what? Two pairs, just like a parallelogram. Remember, these ones, they take from what? A parallelogram. So the trapezium, it is the only one that has got what? One pair of parallel sides. So the answer was going to be C. All right, section B, we are given question number 2 and question 2.1, simplify without using a calculator. All right, so let's see the first part. What is it that you're supposed to do? This is just an expansion of brackets. Simplify, expand the bracket. As we can see, there is a bracket here. So the 4, which is outside of the bracket, is supposed to expand. Distribute by what? For each and every term. So that's it. 4 times x. That was going to be 4x. All right. 4 times -1. That's a -4. Then we are going to add this 5. Okay. So the 5 is not part of the bracket. You add to what you have expanded. You have expanded with 4. And this is what you got. 4x minus what? Minus 4. So you must add the 5, this one. It was not part of the brackets, all right? So adding these, as we can see, we've got the like terms. That is the -4 and the 5. So that's 4x minus 4 plus 5 is just same as 5 minus 4, which is what? Which is 1. Yes, they say do not use a calculator, but guys, you can even just use a calculator to verify these numbers, -4 plus 5, like that. You can just use a calculator. No one is going to know that you have used a calculator there. All right, then let's check on 2.12. What is it that we are supposed to do? There are brackets again, just like the previous case. The first one, 3x minus 1 to be expanded by x. Another one, the x squared minus x plus 7, this one, to be expanded by what? By a -2. So let's expand. That was going to be x times 3x. X is multiplying 3x. Remember, multiplication, you add exponents. If the bases are the same, we are going to add exponents. So that's a 1 and a 1. So we add. So this one is just like there's a 1. So it's 1 times 3, which is 3. Then on x and x, you add the exponents. So that was going to give us what? X squared. 1 plus 1, which is 3x squared. All right, so that was going to be 3x squared. X times -1, that's -x. Okay, we are done. The -2 multiplies, expands everything. So it's just like multiplying to the coefficients of the variables that you're given. So it's -2 times 1x squared, which is -2x squared. -2 times negative. That's a negative. So negative times a negative, remember, is going to give us what? A positive. So that's positive 2x. The -2 multiplies the -7. So negative, positive, that's what? A negative. So that was going to give us -14. So with this, we can collect the like terms as we are to simplify. Thus, we have got 3x squared minus 2x squared. These are like terms. So 3 minus 2, 3 minus 2, that's 1x squared, which is same as what? As x squared. We also have the part of the like terms minus x and the 2x. Remember, same variable, same power. So minus x and 2x. On minus x, it is just same as what? -1. So it's -1 plus 2. -1 plus 2, which is 1. So it was supposed to be 1x. 1x, which is 1x is same as what? Is same as x. You can just write it as x. Then there's a -14, which is no other number to be added to. We do not have any other constant, like maybe there's a 3, there's a 4, there's what. We do not have any other constant, so thus it is just going to remain as it is, -14. All right, so that was our answer. From there, we cannot do anything. There's nothing common. There's no like term to be considered there. We are done. All right, let's consider another part, which is now on 2.13. We are given to simplify again. There is a bracket raised to the exponent of 0. Remember, any number to the power of 0 is 1. So the whole bracket when raised to the exponent of 0 is what? It's 1. So that's going to be 1 plus p. Then here we need to expand the bracket that we are given by what? By the negative 2 that is outside of the bracket. So that's negative 2 times p, which is negative 2p. Negative 2 times a 1. Negative 2 times positive 1, which is what? Negative 2. Positive, negative. It's what? Negative. So that's it. Let's collect the like terms. As we can see, there is p here and there is minus p. So collecting the like terms, it is just like 1 minus 2. 1p minus 2p. So it's 1 minus 2, which is negative 1p. So negative 1p, negative 1p can be written as negative p. All right, so that's a negative p. Then on the numbers, we have got the 1 and the negative 2. So that's we're going to subtract. That's 1 minus 2, which is what? Which is negative 1. Like I said, if you do not understand your directed numbers, guys, use your calculator. Do not even worry. No one is going to know that you have used what? Your calculator there. So 1 minus 2, that's what? A negative 1. Okay, let's check another part of the question. Determine the numerical value of this expression provided that y is equal to what? Minus 2. If y is minus 2, it's a given statement that you must put into consideration. Where you see the y, substitute, replace it with what? Minus 2, just like that. So let's substitute. That's 5y squared. So the y is minus 2. So a product, 5y squared. It is just like 5 times y squared. It is just like 5 into y squared. It is the same thing. So if it is like that, we can take the y, which is minus 2. So that's minus 2. Then we must square it. All right. So that's like this. The minus 2, which is representing what? The y value. Then we square it. Minus 6 into what? The y value, which is negative 2. As we are given that y is what? Is negative 2. Then plus 1. As it is, you substitute where y is, taking note of how it is written there. They can say 5y to the exponent of 3. So it means 5, you substitute the y, which is minus 2 to the exponent of 3. How is that? How is the presentation actually of the part of y, where y is given? All right, so let's simplify, guys. That's 5 into negative 2 squared means negative 2 times negative 2, meaning to say we're going to get what? A positive 4. Then negative 6 times negative 2, that's a positive. Negative times negative, that's a positive 12 plus 1. All right, there is a bracket 5 times 4. A bracket 5 times what? Times 4, which is 20 plus 12 plus 1. So that's it. Let's add all these numbers and see what we're going to have. 20 plus 12 plus, that's 32 plus 1, which is what? Which is 33. You can also use your calculator just to verify. 20 plus 12 plus what? Plus 1. So that's a 33. So these are the questions that are typical exam questions. On question number 3, use the equation to find the value of t in the table below. So we have got the equation y is equal to minus 3x minus 1. What does it mean? Remember the relationship from our functions. For the value of x that we substitute as our input, we must obtain the value of y as the output. So when x is minus 1, y is going to give us a 2. When x is 3, y is going to give us a negative 10. So what if this x is equal to t? It means in place of x on your input, you substitute a t. Y is what? Y is the output, which is -7. So in place of y, we're going to put a -7, the output. This is equal to minus 3x. X, our x is what? Our x is t. So that's 3 times t. Or you can just solve as x as it is, no problem. That is what it means. So you substitute what y represents, -7. What x represents at that moment, a t, as it is given there. So let's solve for t. -7, all right, here we can just take the -1 to the other side of the equation. That's -7 plus 1. The moment it crosses the equal sign, remember, it changes the sign. So it was going to be -7 plus 1 equal to -3 times t, which is -3t. So that's -7 plus 1, -6, which is equal to -3t. So divide by -3. As we can see, that's a product here. So divide, that's our t was going to be what? -6 divided by 3, which is what? Which is 2. So that's t is equal to 2. Okay, just like that. So it's an equation. You use the relationship that you understand from these functions, form an equation by substituting what y represents at that moment and what x represents at that moment. Meaning to say, you have formed an equation where you must solve for t, because it's an equation that you have formed. All right, let's consider 3.2. Solve for x without using a calculator. 3.21, that's 5x minus 7 is equal to 13. Solve for x. So let's get rid of the -7. It's going to be to the other side. So that's 5x is equal to 13 plus. The moment it crosses the equal sign, it changes the sign. Or you ask yourself, how can I get rid of the -7? I add 7 here. I also add 7 so that this cancels. So that is it. So 5x is equal to what? 13 plus 7. That was going to give us a 20, and divide by 5. As we can see, we've got what? A product. So x is going to be 20 divided by 5, which is what? Which is 4. So guys, the product, just like here, -6 is equal to -3t. It was a product. So you divide by what is affecting the variable that you are to calculate. What is affecting x is what? Is 5. So divide by 5. All right. So that is how these questions can be given. As 3.22, we are given again to solve for x, given an exponential equation. So there are so many ways on how to solve here. All right, let's start by getting rid of this -1. It is nothing actually to give or to affect the fraction part. So let's get rid of that one. It is a negative. We are subtracting -1. So let's take it to the other side of the equation. The moment it crosses the equal sign, remember, it changes the sign. So it was going to be 2 to the exponent of x times 2 to the exponent of x plus 1, everything over 16, which is equal to, we have taken the -1 to the other side of the equation. So that's 7 plus 1, which is what? Which is 8. So that was going to give us 8. Again, on solving here, there are so many ways. We can rewrite these numbers in the base of 2, because we can see the simplest base is 2. So 16, rewrite in the base of 2. 8, you can also rewrite it in the base of 2. But as we can see on the numerator, there is a multiplication. So meaning to say, we can use the laws of exponents when it is like that, when the same bases are being multiplied. X to the exponent of a times x to the exponent of b. Same bases. When multiplied, we do understand that we must add the exponents. We must add the exponents. So there we have got the same base. The base of 2, the base of 2. Under a multiplication, add the exponents. So that's 2 to the exponent of x. We add the other exponent. So the first one is x, then we add this one, which is what? Which is x plus 1. So that's it, 2 to the exponent of x. This is 1 times x, which is x plus 1. So that's 2 to the exponent. We've got like terms, x and x here. That's going to be 2x plus 1. We add these two. So that is what we're going to have on this part. So 2, let me write it here, 2 to the exponent of 2x plus 1. From the numerator, we just simplify the numerator. But everything is over what? 16 in the base of 2. It is same as 2 to the exponent of what? Of 4. Yes, they said you do not use a calculator, but you can even check this, guys. Remember here, we can say 16, punch it in your calculator, is equal to. Then you're going to use this button shift. So you're going to use this shift. That's shift, then fact. This one, shift, then you press this fact button. All right. So that is how you can simply have it. So shift fact like this, 2 to the exponent of what? Of 4. You can use your calculator to verify. Anyways, let us move on to 8. In the base of 2, that's 2 to the exponent of 3. 2 times 2 times 2. 2 times 2, 4 times 2, 8. All right. So we have got same base, the base of 2. But as we can see, from the left-hand side, there is a fraction, which makes it to be a single term under the base of 2, under the same base, a division. What are you going to do? Subtract the exponents. As we can see, we've got the same base under a division. So x to the exponent of a, when divided to that of b, you subtract the exponents, a minus b. So that was going to be 2 to the exponent of this 2x plus 1 as it is. Then we subtract the 4. So that was going to give us 2 to the exponent of 2x, collecting the like terms, 1 minus 4. That is a negative 3. So that is what you're going to have here. By simplifying this side, making use of your laws of exponents. So that's 2 to the exponent of 2x minus 3, which is equal to what? On the right-hand side, it is 2 to the exponent of 3. So from this part now, we can see that there is a base of 2 and a base of 2 that are equal. It is a single base to a single base. When this occurs, that x raised to the exponent of a is now equal to x to the exponent of b. A single term to a single term. Same bases, therefore the exponents are equal, a and b. A will be equal to b. It is the same thing, the base of 2, base of 2. So therefore equate the exponents. 2x minus 3 must be equal to this. All right, so that is the case. 2x minus 3 is equal to 3. Then we are back to those linear equations that we have been solving before. This one is equal to this. How are you solving these linear equations? All right, you can take the minus 3 to the other side of the equation. It becomes a plus there. So that's 2x is equal to 3 plus 3. Or you just add 3 both sides. Add 3 both sides. 3 plus 3, that's 6. Divide, since we've got what? A product there. So that's x is equal to 3. Just like that. Or we can have this equation, guys, in so many ways. We could have from this original part here, you take the minus 1 to the other side, which is okay. All right, so this is another way that we could have answered this. Whilst you're on this stage, you can see that this is 8, which is same as 8 over 1, to be a fraction like what we can see on that side. So this allows us to cross multiply. So if I cross multiply, it's 1 times this as it is. 2 to the exponent of x times 2 to the exponent of x plus 1, which is equal to 16 multiplies 8. So 16 times 8 was going to give us 128. We are back here on the left-hand side. Same basis under a multiplication. So you're going to add your exponents. So guys, we already added these exponents and we got 2 to the exponent. We got 2 to the exponent of 2x plus 1 equal to what? 128. Can this be written in the base of 2? So we can even try our calculator. That's 2 to the exponent of what? Of 7. If you know your number base, if you know your bases now, you know that, okay, 2 times 2 times 7 times. Once we see this condition, a single term to a single term, same bases, equate them. Equate the exponents as well. As we can see, the base of 2 and the base of 2 are the same. So therefore, this must be equal to this. So therefore, we've got 2x plus 1 equal to 7. So solve for x, this to the other side, or subtract 1 on each side of the equation. That's 7 minus 1, which is 6. Then divide by 2. X was going to give us what? 3. 6 divided by 2. So that is how these questions can be given as. It's another way that you could have used to solve this part. All right, let's consider 3.23, which also is similar to this one. It is similar to the previous question. These are exponents, only that they have already simplified here, so we can choose to work out any way that we want. From the previous calculation, we saw that a division, you subtract the exponents. So it was going to be x to the exponent of x minus 5, since we are referring to the same base. Then we subtract minus 3. Take note. Same bases under a division, you subtract exponents. So this is equal to 27. Okay? Simplifying this was going to be x to the exponent of, let us simplify. Remember, negative, that's a positive. So it's x minus 5 plus 3, which was going to give us what? X minus 2. Minus 5 plus 3 is what? Minus 2. So that's x to the exponent of, that's, where am I getting the x? This is 3 to the exponent of x minus 2. All right, so it's going to be x minus 2 here. And that's equal to 27. Can we rewrite it in the base of what? In the base of 3. 27 is same as what? 3 to the exponent of 3. 3 times 3 times 3. We have 27. So we are back to the previous condition, same basis, meaning to say, therefore, the exponents will be equal, as we've got same basis. So therefore, we have an equation that's x minus 2, the exponent must be equal to what? To 3. So let's solve for x. Take the minus 2 to the other side, that'll be a plus, or simply add 2 both sides, as we've got a negative. So we add 2 both sides to get rid of that negative 2 on the left hand side. So x will be equal to 3 plus 2, which is what? Which is 5. This is how these questions can be given as. So many ways of answering. X is 5. We could have also attempted this question similar to the previous question, where you can also cross multiply. This is same as 27 over 1. So you can also cross multiply. 1 times this, 3 to the exponent of x minus 5 is equal to 27 multiplies 3 to the exponent of what? Minus 3. So that's 3 to the exponent of x minus 5 is equal to what? We rewrite the 27 in the base of 3. We do understand this is 3 to the exponent of 3 times 3 to the exponent of minus 3, where the bases are the same. Under a multiplication, we add the exponents. So we're going to add minus 3, which is what? A plus and minus, that's a minus. So 3 to the exponent of 3 minus 3, that's 3 to the exponent of 0. So 3 to the exponent of x minus 5 on the left-hand side is equal to what? 3 to the exponent of 0 from this one. By adding the exponents. But there's a plus and a minus. So at the end, you have what? A negative. So 3 minus 3, which is a 0. Then from there, take the bases, check the bases. If they are the same, as we can see, they're the same. So therefore, we can simply equate our exponents. Since we've got what? Same bases. So therefore, this exponent, which is x minus 5, all right, so we've got an exponent there. X minus 5 must be equal to what? Must be equal to this exponent, which is what? Which is 0. So solve for x. Take the minus 5 to the other side of the equation. It's going to be a plus, or you simply add 5 both sides of the equation. That's x is equal to 0 plus 5, which is what? Which is 5. Same answer as before. As before. Same answer as before. Meaning to say there are so many ways of attempting these questions. Do revise as many questions. Figure out how to attempt. On question 4, 4.1, we're given in fig below, AB is parallel to CD. The indication of our parallel lines is given, and we are asked to calculate the size of the following angles, giving reasons. 4.11 x. So what is going to be the value of x here? All right, so as we are given that these lines, they are parallel, we can see that the x and the 80 degrees, they do form a z, alternate angles. All right, where a z is formed, or when any like this is being formed, we have got what? Alternate angles which are equal. So x and 80 degrees will be exactly the same. So x is equal to 80 degrees. These are alternate what? Angles. Since AB is parallel to what? Since AB is parallel to CD. So that's it. So this one is 80 degrees. So to find y in that case, all right, there is also our parallel lines. So we've got this 60 degrees outside of the parallel lines, y inside of the lines that are parallel, y is inside. Remember those angles that do form an F, corresponding angles where we form an F. This one is inside, this one is outside. This one inside, this one is outside. So we've got this one, which is inside our parallel lines from the F. Okay, we can have our F like this, as we can see. So that's y and 60 degrees. So meaning to say automatically y is equal to what? 60 degrees. Those are corresponding angles, the one that form a Z. Corresponding angles, as we are given that AB is parallel to CD. It is the same thing that is happening on X and Z. They are corresponding angles. So we can use that Z is what? X, which is 80 degrees. Yes, they are also vertically opposite angles from the 80 degrees. So as you can see, guys, so many ways, as long the statement that you are giving is what is true. So Z can be determined. So Z, I do not know, guys, according to you, are you going to use Z equal to X? If you use this one, your reason will be corresponding angles. But also Z is equal to 80, this one, because of what? Vertically opposite angles. So we can simply say Z is equal to 80 degrees, this one. They are vertically opposite angles, this one. They are vertically opposite angles. So you can simply use that one. Whatever case, as long the statement is okay. All right, so Z is equal to 80 degrees from what? From vertically opposite angles. Okay, since we have got two straight lines that are intersecting. So that is how these questions somehow they are given as. Then 4.2, in this diagram we are given that RS, all right, that is RS and TW, they are parallel. Okay, so the two lines, they are parallel. Find the size of each of the following angles. Give reasons. Find the size. All right, so the first one is angle A. Angle A, this one, it has nothing to do with the parallel lines, but we can see that VWU is a straight line. So what is it about angles on a straight line? They add up to 180 degrees. If I take these three angles, combine them together, we must obtain 180 degrees. So therefore, A is equal to what? 56 degrees. These ones from 180. So it's simply going to be 180 minus, you add the 56 and the 75, the other angles that are on a straight line. Remove them from what? From 180. Because we said all these three angles, they sum up to 180 degrees. Angles on a straight line, right? So that is going to be your reason there. So A is equal to 180 minus the sum of these two, that's 131 from your calculator. You can even use your calculator there, then subtract. That was going to give you 49 degrees. Okay, so if A is 49 degrees, let us put it back here. This angle A is 49 degrees. Then what about this angle 4.22, which is SVW? SV to W, SV to W. This angle, which is the outer angle, the exterior angle. What is it about the exterior angle? There are so many ways of answering this. All right, firstly, we can see that angle R and angle A, they are equal. Alternate angles where we form a Z. Alternate angles, since these two lines, they are parallel. So this angle R was going to be 49. Alternate angles, all right? So let's start by finding angle R. Angle R is equal to 49 degrees, which is angle A from what? Alternate angles, as we are given that these two lines, they are parallel. RS is parallel to TW, right? Since our RS is parallel to TW. So if this angle is 49 degrees, what about angle SVW? The exterior angle, we do understand that in any triangle, this exterior angle represented must be equivalent to what? To the sum of the opposite interior angles. Remember, I referred to this part on our properties, that is working with our properties of 2D shapes on our triangles. If there is an exterior angle, an angle which is outside of the shape, this one, it is equal to the sum of the opposite interior, this one and this one. So V is an exterior angle SVW. So it is equal to the sum of the opposite interior, the 49 and the 56 degrees, those ones that are opposite to the interior. This is our interior, but those ones that are opposite to that. So that is how we're going to find the angle SVW. So therefore, our angle SVW is equal to, we said, angle R plus angle W, all right? 49 plus angle W, which is 56. So you add these two, all right? So that's the exterior angle of what? Of a triangle. Exterior angle of a triangle. All right, it is equal to the sum of the opposite interior. So that is it. We're going to have our angle SVW. So SV W is equal to the sum 49 plus 56. That was going to give us 105 degrees. Just like that. As long you've got your properties. As long you have got your properties of the shapes, 2D shapes, and also your properties of the straight lines. Geometry of what? Geometry of your straight lines. Okay, let's figure out on another part of the question 5, which two triangles are congruent? Remember, congruent, they must be exactly the same. So by looking into our triangles and the angles, the way that they're given, we can see that the first one and the second one are exactly the same. If you're just to pick this triangle, just to redraw it in this way. You see where this angle A is, it was supposed to be here at M. If it was at M, we're going to take all these triangles to be congruent. But look where the angle A is here. From a side, like if it was from this, I want you to figure out from X, from Y here to X. That is where we've got these two lines, okay? From R to T. From N to M, where we've got two lines. Then the angle is at the end. So from Y to X, the angle is at X. The angle is at T. But look here, the angle was supposed to be at M. It is at N. So this one is totally out. The last one is totally out. It does not correspond. Congruent means exactly the same. Exactly the same. So meaning to say, from there, we have got the side X to Z. Exactly the same as T to S. 1, 1. So that's YXZ. Triangle Y to X to Z is congruent to as it is from R to T to S. And the reason that we're going to give there is going to be side angle side. All right. So that's side angle side. Remember the case of your congruency. In the diagram below, ABC is similar to this triangle. Determine the length of X. Remember, from similar figures, the ratio of sides is the same. Whenever we have got these similar figures, we do understand that the ratio of sides is equal throughout, is the same. How do you find that ratio? Ratio of corresponding sides. It's like this. AB as a side. AB over the corresponding D to E. All right. Must be equal to, we move on, BC. So this is BC over what? E to F. Over EF. This must be equal to from A to C. All right, A to C over what? D to F. Like that. That's the ratio of sides from similar figures. Anyways, the question here was to calculate or to determine the length of X. Since they are similar figures, you write the ratio of sides like this. Then you figure out which part that represents X. X is what? Is DE. So the question is for you to find DE. This one. This is our DE. From where? AB over DE. Do we have AB? A to B, it is there. All right. BC, do we have BC? BC is unknown. We do not have this. It's Y there. So we cannot take this one because it's not complete. E to F, yes, there's something there from E to F, but we do not have BC. So let's check the other one. AC, A to C, we have got that part, which is 15. DF, from D to F, we also have this part. So we are going to equate what we are to calculate, which is X, which is representing what? DE. Remember, we say DE, this one. So we are going to take this ratio to a ratio which is complete. We cannot equate these two because we do not have what? We do not have BC. BC is missing. So you'll be having BC missing. Also, DE, we do not have that. So you write your ratio, then look into the ratio. What are you given from your diagram? And see which one are you going to use. So you're going to take the first one to the last one. That's AB over DE is equal to the last one, AC over DF, where we have got everything given, not unknown values like this y there. It's an unknown. We do not know that. All right. So let's find our DF. AB is there. Remember, AB from our diagram is 12. So that's 12 over DE, which is equal to AC, which is also given from A to C. That is what? That is 15 over DF. Remember, from D to F, we are also giving that one from our diagram, which is what? Which is 5. So we have formed an equation. Solve for DE. It's an equation now where you must solve for what? For DE, which represents X. So you can even write X there since DE represents X. So in place of DE, let's put X there and solve for X, just like that. It's an equation, guys. So let's cross multiply since we've got a fraction and another fraction. So cross multiplying this, X times 15, that's 15x equal to 12 times 5, which is probably 60 there. That's 60, then 15 divided by 15. Our x was gonna be the 16 divided by 15, which is what? Which is 4, just like that. Just like that. So this is how these questions can be given as just study the diagram. Similar figures, similar triangles are equiangular, which is very correct. They are equiangular, but the major case is ratio of corresponding sides is same, equal throughout. On question 5.3, in the diagram, we are given that the side GH and the side G to J, they are equal. So we've got this indication that these two sides, they are equal. Given that angle H is 62 degrees and angle I, G to J, I to G to J, this one, it's 20 degrees. And there is 62 here. Determine the value of 5.31 R. All right, our angle R here. How can we determine that? Let's start by the lines that we are told they're equal. Because here we cannot, guys, like as you can see, it's a limited. So let's start by knowing the properties in an isosceles triangle, which is fine. But we do understand that from these equal sides, the angles opposite must be equal. So the 62 degrees at H must be exactly as the angle T here, which is what at J. So this must be 62 degrees. Angle T is equal to 62 degrees. These are angles opposite what? Equal sides. Okay? So if angle T is 62 degrees, therefore angle R can be calculated as we do understand angles in a triangle, they add up to 180. So angle R will be 180 minus the angles that are inside the triangle, the 62 degrees and the 62 degrees representing T. Remember, we said angle T is 62, opposite angles opposite equal sides. So we have formed an equation. Solve for R. So here we are referring to angles in a triangle. So let us solve. So R is going to be 180 minus the sum of these two, 62 plus 62. That was going to give us 124 degrees. Then the difference there is our R. So 180 minus 124 is 56 degrees. Okay, just like that. So we have got angle R there, which is 56 degrees in case we might need to use that angle. All right, then on another part of the question, which is 5.32, angle P. So P, is this angle there at I here, angle P. So there were so many ways to attempt this one to answer for that angle P. Since we know that angles in a triangle, they add up to 180 degrees. So for us to use or to find angle P, we're going to use the outer triangle, the bigger triangle from G to H to I. So knowing that angles in a triangle, they add up to 180 degrees, we are going to subtract the angles that are inside, that is working with the outer triangle, the outer one. So which angles are we going to subtract from 180? The angle at H. All right. So we are working with the triangle GHI. In triangle GHI. So this is from or in triangle GH to I. Okay, no problem. So we're going to subtract, like I said, 62 degrees. And also the angle which is at G, the angle there at G. And the angle at G is the sum of these two angles. It's a combination of these two. You have to combine the 56 and the 20 together. So the 56 and the 20 together, they are part of a single angle. It's now a single angle, which is our angle G. It is the sum of these two angles, combine them. So removing these angles from the 180 degrees of the outer triangle will give us what? The remaining angle, which is P. So that's P. All right, so these are angles in a what? Angles in a triangle. All right, so we're going to have angles in a triangle. So to find angle P is going to be 180 degrees minus add everything that you are given there. That was going to give us 132 degrees. So 180 minus 132, which is 42 degrees. Okay, so that was it for our angle P. Then on question 5.4, in this diagram, we are told that from H to J, it is the same as from J to K. These two, they are equal. So what is that we know about such condition? A triangle that is formed to be an isosceles triangle, and on an isosceles triangle, or from this property, opposite angles will be exactly be the same. So the angle at K, which is 2x minus 15, is the same as angle H1, 2x plus what? 15 degrees from that condition of opposite angles. All right, anyways, that is what you're given. Then also O to J, this one, it's 6 centimeters. And the angle from this one is 2x plus 15. Okay, no problem. So the questions here were 5.41, calculate with reasons the value of x. All right, angle x there, which is at J. All right, so this part here, remember, we have got, all right, so here, I want to show you the triangle. Let's say, let's work with triangle HJK. All right, so in this triangle HJK, I want us to see what is happening here. This is the triangle that we are working with. And we are saying this triangle is an isosceles triangle. So the base angles will be exactly the same angles that are opposite what? Equal sides. So this one, let us just write it as a statement. Remember, we said angle H1 is equal to angle K, which is 2x plus 15 degrees. That is this angle K, okay? Angles opposite what? Angles opposite equal sides, okay? So if these two, they're equal, another part is x. J1 is equal to x. Remember the properties of an isosceles. The line that we're going to draw is going to be at perpendicular. These diagonals will be bisected. So it will be actually at perpendicular, bisecting these two angles from the isosceles triangle concept. So if J is x, J1 is going to be also x. So angle J1 will be x. So that's a diagonal bisecting angle J. from the properties of an isosceles. Since this is a diagonal, it's going to bisect angle J. Properties of an isosceles triangle. So that's if angle J1 is X. Are we seeing that we now have all the three angles inside the triangle? So we can form an equation, as we do understand that angles in a triangle, they add up to 180. So if I take angle H1 representing 2x plus 15 degrees, which is our angle H1, plus if I add this one to angle K, which represents angle 2x plus 15 degrees, all right, which is our angle K. And also add this to angle J, which is our angle J is X and X combined together. There's X here, there's X. So X plus X is going to be 2X. All right. So we must add that X plus X, which is 2X. We must obtain 180 degrees angles in a triangle. That's it. So thus we have formed an equation. Angles in a triangle. So with this equation, we can solve for x, collecting the like terms. There is x here, 2x, add to another 2x, add to another 2x. Those are the like terms. Combine them together. So 2 plus 2 plus 2, that's what? That's 6. So 6x. The other part of our like terms is on the constants, the 15 add to another 15. So 15 plus 15, that was going to be 30. So that's 30, okay, which is equal to 180 degrees. So you can solve for x from there. Take the 30 to the other side of the equation. It's a plus, it's going to be a minus there. Or simply subtract minus 30. Subtract 30 degrees both sides, so this can cancel. So that's 6x is equal to 180 minus 30, which is 150 degrees, using the product concept. It's a product, so divide by 6 both sides. So x is equal to 180 divided by 6, which is 25 degrees. That's our x. So x is equivalent to 25 degrees, just like that. All right, on another statement, which is 5.42, if the area of the above figure is 45, if the area of this figure that we are given is what? Is 45. This is what we are given. If this figure that we can see, if its area is 45, then 45 square centimeters, calculate the length of h to k. You may use this formula. That's hk is equal to what? 2 times the area, which we are given. What is our area? 48 over what? I to j. Do we have that from I to j? Remember, the diagonals in this case, they do bisect each other, these diagonals. Diagonal bisect another one. So from O to J, it is the same thing as from O to I. From also the properties of if you're dealing with a parallelogram, as we just have something related to a parallelogram, a rhombus, all that concept, they do bisect each other, these diagonals. Same from H to O, it is the same as from O to K. But as we are focused with I to, from I to J, so meaning to say IJ is equal to what? Since we are given that OJ is 6, from O to J, it is 6 centimeters. This one is also 6 centimeters. So the whole of IJ there is going to be 6 plus 6, which is 12 centimeters. So that is the one that we need here, I to J. The whole of that length. You add 6 plus 6, okay? Because diagonals, they do bisect each other. So that was going to give us 12. And that's it, guys. You can use your calculator. We just multiply 2 times 48, which is 96 over 12. And that was going to give us 8 centimeters. You're already given an equation to use. You may use this. They are taking it from the area formula, but already they've made h, k the subject of the formula. Just make sure you do substitute everything properly as it is given. So these are the typical questions, guys, that we might be given in our examinations. Similar to that, the concept is revision of the topic. Get used to the topics that are being asked in your term 3. And this is similar, a continuation to your term 4. Once you understand your term 3, then you know that your term 4 will be perfect. So let's do revise as many questions as we can as we are preparing ourselves for the exams which are ahead of time.